Good morning, student. We are running the series of engineering mathematics, that is exam decoder. Let us start to discuss today's question, that is question number 3. In today's lecture, we are discussing that question. Weightage for that question is 5 mark. Weightage for that question is 5 mark. What his question is asking? Let us start to discuss. Determine whether the relation R on the set A is reflexive, irreflexive, symmetric, antisymmetric, and transitive, where A are given. Those relations which are given in the diagrammatic representation, we want to check that relation is reflexive, or that relation is transitive, that relation is irreflexive, that relation is symmetric, or that relation is antisymmetric. We want to check about that. Means examine. We want to examine for that. Let us start solution for this question. A set are given. What is element? 1, 2, 3, 4. And diagrammatic representation of relation are defined with digraph. 1, 2, 3, 4 are given. And this is the directions are given, means this self loop. 1 is related to 1. Now let us convert this diagrammatic representation. Let us convert that diagrammatic representation into relation format. In simple set relation format. What is, write down R is equal to, in curly bracket, this 1 is related to 1. Therefore, first element is 1 is related to 1. 1 is related to 2. Therefore, this second element 1 is related to 2. This is diagram. 2 is related to 1. This 2 is related to 1. Means write down first of all 1 related to 1 element. Means first 1 is related to 1. 1 is related to 2. Second element 1 is related to 4. Okay. 1 is related to 1. 1 is related to 2. 1 is related to 4. Now go to 2. 2 is related to 1. Therefore, write 2 is related to 1. 2 is related to 3. 2 is related to 3. Are present for here. Now go to 3 and find 3 is related to 4. 3 is related to 4. When you are going to with 4, there is no relation starting from this 4. Means there is no relation starting from this 4. Okay. This is a representation of R. Relation representation. So diagrammatic representation hai, we are converting that relation into set form. Okay, now we want to check this R is reflexive, irreflexive, transitive, antisymmetric. We want to check now. Now let us start. What is the definition for reflexive? 1 1, all element 1 1, 2 2, 3 3, 4 4, whatever may be element are present in that set. Each and every element must be related to self. Self-related element is available in that set. Means 1 1 are available, but 2 2 are not available for here. 3 3 are not available in that relation. 4 4 are not available in that relation. Therefore, 1 1 2 2 3 3 are not available in that relation. Therefore, R is not reflexive. Therefore, R is not reflexive. Okay. Now I want to start irreflexive. Meaning for irreflexive. What is the definition for according to irreflexive? Is simply if you want to check that relations are irreflexive or not, self-related element are not present. If self-related element are not present in that relations, we call that relations are irreflexive relation. But one element which are exist, one which are self-related, but that element which are available in the relation. Means 1 1 is a self-related element, but which are available in the given relation. Therefore, this relation R is not irreflexive. Therefore, that relation is not irreflexive relation according to definition of irreflexive. Okay. Next, we want to check the symmetricity. What is meant by symmetricity? Symmetric relation you want to check. 2 and 3. What are definition for symmetric element? Whatever may be the element are present in that relation, exactly symmetric element which are must be present for that relation. Means if 2 and 3 are present in the relation, if 2 and 3 are present in the relation, then 3 comma 2 also present in relation. Then we call that relations are symmetric relation. Okay. But if you are observing that one element exists in that relations, 2 comma 3, 2 comma 3 are element which are available in that relations are, but 3 comma 2 does not available in that relation. If you observe the relation here, okay, 2 comma 3 present in that relation, but 3 comma 2, 3 comma 2 does not available in that relation. We are able to find one pair. That one pair does not satisfy symmetric property. This pair also exists. Let us see here. 1 comma 2 are available in this relation. Exactly symmetric pair are available for there. If you are possible to find one symmetric pair, we cannot conclude that relations are symmetric relation. Each and every pairs which are available in that relation, symmetric pair must be available for that. If you want to say that relation are symmetric, then you want to check the each and every pair for that relation is available. Now let us choose the second pair, 2 comma 3. 2 comma 3 are element which are available in that relation, but 3 comma 2 does not exist in that relation. Means 2 comma 3 are element which are exist in that relations which does not follow symmetric property. Therefore, we comment that relation is not symmetric relation. The relation is not symmetric relation. What is mean anti-symmetric relation? Anti-symmetric relations means symmetric element, symmetric property does not satisfy. Anti-symmetric element means symmetric property does not satisfy for that relation simply. But 1, 1, 2, 2, 3, 3 are allowed in that relation. But self-related element are allowed. But other than the self-related element, symmetric element does not exist. Then we call that relation is anti-symmetric. Now let us observe for that 1 and 2 are element are present. 1 and 2, 1 comma 2. This is the element which are present in relation R. That same time we are observe 2 comma 1 also present in relation R. 2 comma 1 which are also present in relation R. Let us observe for that. What is here in relation R? 1 comma 2 which are element which are present in relation R. At the same time 2 comma 1 which are also element which are present in R, which satisfy the symmetric property. We able to find one element which are satisfy the symmetric property other than diagonal element, other than self-related element. Then what we are concluded that is not anti-symmetric. What is simply definition for anti-symmetric? That element other than diagonal element, other than self-related element does not satisfy symmetric property. So we are able to find one element which are satisfying the symmetric property. Therefore, we are concluded that by giving this reason for that 1 comma 2 which are available in this relation R and 2 comma 1 which are also belongs to R. Therefore, which satisfy the symmetric property, then we call that R is not anti-symmetric. R is not anti-symmetric relation. Now we want to comment for transitive relation. What is transitive relation? Each and every pairs which are exist in this relation means A is related. What is definition for transitivity? If element A is related to B and B is related to C, then A is related to C must be present in that relation. A is related to C must be present in that relation. Then we call that relations are symmetric relation. Sorry, that relation are transitive relation. A, B, C which are belongs to in relation R. Let us observe for that. Let us choose. If you want to say that are transitive, each and every these possible pairs, all the possible pair, we want to show that. If we want to comment that relations is not a transitive relation, if we are able to show one pair. If you are able to show the one pair which does not satisfy the transitive property, then we directly comment that relation is not transitive relation. But you want to say that relation are transitive, you want to check each and every pairs. All possible pairs which must be true, we want to show that. Let us start to showing for that. 1 comma 1 which are belongs to relation R and 1 comma 2 which also related to which are also belongs to in R. Means 1 comma 1 and 1 comma 2 which are belongs to in relation R, which implies that 1 comma 2 is also 1 comma 2 is also belongs to a relation R. Means 1 is related to 1 is related to 2. It directly get related to by transitive property 1 is related to 2, which is belongs to R. 1 is related to 1 and 1 is related to 4. We directly say that 1 is related to 4. By transitive property, 1 is related to 4 and which is belongs to in relation R. 1 is related to 4. But 1 is related to 2 and 2 is related to 1. By transitive property, directly 1 is related to 1. 1 is related to 1 which are available in relation R, which are belongs to in relation R. But now yes, 1 is related to 2 and 2 is related to 3 which are belongs to R, but 1 comma 3 which are resultant for that. Means A is related to B is related to C and directly A is related to C by according to transitive property. If you want to say that that relations are transitive. But directly by transitive property 1 is related to 3. 1 is related to 3. But if you are observing that relations are, there is no element which are available in that relation 1 comma 3. Therefore, we can conclude that 1 comma 3 which does not belongs to relation R. 1 comma 3 which does not belongs to relation R. We are able to find one pair, means we are able to find one pairs which does not follow the transitive property. Then directly we can say that that relations are not transitive. Directly we can say that that relations are not transitive relation. This is the simple examples. Relations are given, diagrammatic representation of relations are given. He is asking check that relation are reflexive, that relation are transitive, that relation are antisymmetric, that relation are symmetric. We want to check irreflexive. Okay, we are checking easily. Okay, we are stopping here the exam decoder series here. Today one lecture, one question is get completed. Next questions we will discuss into next lectures. Let us stop here.